So, hey everyone, thanks for joining me when I tell you something about how we encrypted 6 petabytes of customer data. And, well, who am I? My name's Andreas. I'm working for Adobe as a computer scientist here in Hamburg. And in my free time, I'm also doing a little bit of open source for the Maven project and for the MapStruct project. But we're here to talk about what we did at Adobe. So Adobe's a big company. We have a broad range of applications, tools and services, and you probably all know a couple of them. So what is it that we're talking about here? Well, you might have heard of the Creative Cloud and the Document Cloud things. And the Creative Cloud is basically the home of Photoshop and Illustrator and InDesign, Premiere Pro, After Effects, but also some mobile apps like Photoshop Touch and Draw and many others. And it's not only the applications, but they also offer some cloud integration. So you can have some cloud storage where you have conversions, renditions of your files. You can do some collaboration, exchange data between the apps on the desktop and on the mobile device, and all that stuff. Then the document cloud, it's a second cloud. That's the home of applications like Acrobat and Sign and some Adobe scan apps that you can use on your mobile devices. And that also offers some integration to cloud storage. There's also renditions for files, conversions between different types of files. You can convert Office documents to PDFs and so on. So now that sounds very similar for both. So underneath, there's a shared cloud. So the shared cloud, that's a set of services that are below those two clouds. And that is what we're dealing with here. So first of all, that's a content repository where you can have files and folders. It offers some collaboration features like, I want to share a file or a folder with someone else or a group of people. And it also offers some processing capabilities like creating thumbnails, creating little pictures of your layers in a Photoshop file, doing conversions between different file types, extracting EXIF metadata and so on, doing search integration, all that stuff. So in our system, we have about more than 100 million users, more than 1 million requests per minute, and we're deploying in 3 regions in Amazon Web Services around the globe. There's also some working going on in Azure, but that's not for today. So technologically, the main pillars are we're using a MongoDB, we're using SQS, so the messaging system, we're using DynamoDB to store stuff, we're using Elasticache, and of course, all those files that are uploaded by users or that are generated by our components, they're stored in Amazon S3. There's all sorts of other services that we use from Amazon and also from our own deployments like Kafka and other databases and so on. But that's what we're using the most. And all of that is developed and operated from our Hamburg office right at the Elbe, next to Fish Auktionshalle, in case you want to visit us. So for us, the highest priority is always to keep the customer data safe and secure, because obviously they entrust their most valuable things, the work that they create in either privately or in media agencies or whatever, they trust that the files that they upload are not exposed to someone else. So what do we do? Of course, we have all those common sets of controls in place. We do some strict management of the AWS accounts, the IAM roles that are minimal to what each service can do. We have automated security audits on those things in the cloud. Basically, that's what everyone should do when deploying to a cloud, and that's all the best practices there. So now let's take a look back to 2015. And well, our own security standards were raised in a couple of areas. And there were also some certifications coming up, like, for example, the PCI data security standard. Who has heard of that? Yeah, some. Whenever you want to store or process documents that may contain credit card numbers or even hints of those, you have to deal with that. And a lot of certifications require you to have encryption at rest. So what does that mean? Each file you put on any disk or in S3 or something needs to be encrypted. Oh, yeah, okay. Encryption, that is easy. You have a key, you encrypt the file, and you can decrypt the file with the key again. Okay, but how do you store the key securely? How do you distribute it in your system? Obviously, you can't just commit the secret key to your configuration and deploy it. So it's a whole can of worms that you would open up there if you want to do this all on your own. And luckily, AWS came out with a fairly new KMS system. So that is a key management service that was introduced a bit in 2015 or a bit earlier. But that actually seemed like the thing we want to use. So what is it? So let's just go through how you would use the KMS system. So you generate a custom key, and instead of getting a key, you get a resource name for that, a key reference. So that is somehow bound to an AWS region and an AWS account, and it has some name. So, and that key reference can you use to pass it along to some AWS operations, like save that file to S3. You pass with it the key reference, and then AWS will automatically encrypt that file on disk. And if you read that thing back, it'll be automatically decrypted for you. But only if you have, if your account or the user or the IAM role that you're using is allowed to read that key, has access to that key. So any usage of those keys is traced in CloudWatch, so you can always see what part of the system has used a specific key at what time and for what. So that's also quite an important thing to have for all those certifications. Okay. And another thing is, if you revoke a key, you can prevent all further usage of it, of course. You can't decrypt any files that you have created with that key. And such a revocation of a key can be either temporarily or it can be permanently. So if you permanently delete such a key, all your data, is lost and you can't ever read it again. So now how does it work? It's basically some special AWS systems there, some special hardware that is involved, and so extra hardware, extra systems, there are rate limits. So whenever you introduce the usage of KMS in your system, you have to you have to think about the additional rate limiting. So at the moment, it's 1,200 operations per minute. So like reading and writing of encrypted data. And that is per account and per region in AWS. And if you ask nicely, they can raise those limits for you. And back when we started, those limits were, I think, about 100 operations per minute or so. And well, they had to raise it for us. An alternative to avoid that rate limiting is to retrieve and to cache a special data key. And with that data key, you can do the encryption and decryption in your client code, in your server that you run on AWS. And well, of course, you have to deal with the caching and the invalidation of that data key, and also retrieving data keys is subject to rate limiting. But you can also use that to encrypt and decrypt sensitive data before you send it through something like SQS or Kafka between different services. Now, you might have noticed that does not prevent you from having someone steal your data if someone breaks into your AWS account. So yeah, why are we even dealing with that? Well, the security benefits that this brings you is it allows your clients to manage their own keys in their own AWS accounts. They have the control over that key. And if they either choose to move their data elsewhere, or if they suspect that some data breach happened, either because their access accounts have been made public somehow, or in AWS or on our side something went wrong, they will be able to just revoke their key temporarily or permanently and make all the data unreadable. And also, in the obscure case that someone's stealing the hard drive from AWS, well, they won't find anything useful there either. So, what do we do when we want to create an encryption system? Well, let's see what we need. So, of course, we want different clients and different enterprise customers to be able to define their own keys and use different keys for themselves. Then we want some API for them to trigger an encryption of their data. For example, if they roll a key, all the data needs to be re-encrypted, because if they delete the old key before all the data is encrypted with the new key, well, they can't access it anymore. So that's something we need. And we need to be able to track the status of the re-encryption. And on the non-functional side, well, there's this rate limiting in KMS, as I said, and we have a database that doesn't scale indefinitely. So we need to make sure that whatever we do in this re-encryption service, it must not disrupt the online transactions of our services. So, but still, it needs to be somehow scalable, it needs to be resilient, it needs to be able to throttle itself down in case we actually do hit some rate limits or so. Yeah, and that is what we created with Kryptonite. It's an asynchronous encryption system, and I'm going to give you a short overview of how that works. So, we have a web API, rather simple, and the client posts an encrypt command telling the system to encrypt all the files of all the users within an organization, its own organization, obviously. So then we create a message, put it into an SQS message queue, the org queue, and it just says basically encrypt that organization. We put something into a DynamoDB table that says, well, I'm creating your job, and we send back the response. and we have a pointer to the status API pointing to that status entry. So we have one message in that one org queue. Now, another part listens to that org queue and reads the message and finds all the users that belong to this organization and creates messages for each user in that organization and says, here, encrypt that user. And that is being put into another queue, the users queue. And we update the status table. And now we have created n messages for that one org queue message. Now it goes on, encrypt the user. I read one message to from that users queue, and what do? Of course, we check what content does that user have, and what content records belong to that user. Create a batch, a batched representation of those content records, and put it into a content queue. That's the stuff that we want to re-encrypt. And once we've found all the content entries for one user, we can say, well, the re-encryption is now running. And we've created a lot of messages again. And of course, you can imagine what happens now. We actually use those content batches, and with that information, we can point to specific S3 objects and re-encrypt them. So, and when we encrypt an S3 object, we also set a marker in the MongoDB record that tells us, hey, we've encrypted that object with this AWS KMS key reference, so that later on we won't need to re-encrypt it again in case the user just sends in this re-encryption message again with the same key. And once we've encrypted all the objects for all the users in that organization, once we've read the last message there, we can say we're finished. Okay, so we've created a lot of messages and a lot of requests, but it all is asynchronous, so many things can run in parallel, and we can use that to scale out this system. Now, in case that's too boring, let's look at some code. How do we actually encrypt a single object in S3? Well, that's easy. We can just copy it onto itself. And we use a copy request, and the source bucket name and source name is the same as the target bucket name and target name. We just have to add the key reference that we want to use, and then send out the copy request. With that, the e-tag of the copied object changes. So we have to take care of that somehow as well. And a tip, if you have larger files, you can use multipart copies. And we found that everything above 10 megabytes can benefit from using multipart copies. Okay, now we've seen that is now a very big system, and if we let it run loose, it could scale to any amount of instances and could easily disrupt all of our systems. So what do? We have Hystrix to put in some resilience, to put in some rate limits when doing all the S3 and KMS requests. We have circuit breakers that stop processing of messages in case we hit some limits, or we have connectivity issues with one of the downstream services. And we also deal with timeouts and retries there. And we've tested that with Chaos Monkey, and that worked quite well. Now, if you develop such a system that relies heavily on such AWS components. Local development can be quite painful, and also if you want to test your application within the build, you'll have to use some mocks. And what we're doing is we're using Dockered mocks for everything there. So for SQS, we're using Dockerized ElasticMQ that implements the AWS SQS API. For DynamoDB, Amazon provides a local implementation, a mock implementation that we've Dockerized. For MongoDB, of course, there is an official image. And for S3, well, we had to create our own mock implementation there because it had to be capable of HTTPS because, well, the S3 client won't communicate with an HTTP endpoint if you enable the encryption stuff. And also the handling of the encryption headers and so on is a bit different and will require some other responses in those messages. And we also, well, support the multi-part upload and multi-part copy and so on. And last month we've open sourced that finally, and it's on GitHub. It's available on Docker Hub. If you have any need for things like that, check it out. Okay, so now where are we today? The initial encryption of all that data, that took months. So we had to take care of the load on the MongoDB. We had to take care of those rate limits in KMS that were quite low at that time. So we had to interrupt a couple of times and throttle quite extensively. But now everything's encrypted, and everything that comes in new is also encrypted. And we're using a default encryption key at the minimum for everything. And clients that have special needs for compliance or enterprise customers can bring their own KMS keys, and we use that. And in other parts of the system, we now also use those KMS data keys to encrypt sensitive data that is being passed between systems, for data in transit. For example, when we send SQS messages to other parts of the system. So check, we're safe now. Okay, and that already concludes my talk. If you have any questions, ask them now, contact me later, and in case you're interested, we're always looking for people. Check it out. Okay. I actually don't know, but it's a lot, yeah. So saving a couple of petabytes brings you quite some return.
I have a little question.
Yep.
In the beginning, you stated that you use like continuous auditing.
Yeah.
Can you tell a bit more about that? Maybe?
Okay, the continuous security auditing is a set of tools that continuously monitor all our AWS accounts. We have hundreds of thousands of them, I don't know. And all those accounts are checked to if they are properly protected. They are defining the required access roles for certain users. If there's any rogue EC2 instance running, maybe having some SSH port open to the world or so on. If anything happens, that will raise an alarm immediately, and well, you either get called if someone can track it down to yourself, or that will just be terminated and fixed. And that runs continuously.
Do you use commercial tools or stuff like, for example, do you use already Chaos Monkey, maybe Security Monkey? Or?
I actually don't know. I think it is an open source tool that is being adopted there. The security engineer who takes care of that, I think he gave a couple of talks already on that. You can find that on Twitter on at Adobe Security. They have an own Twitter account, and I've seen that talk popping up there.
It's quite interesting or your approach to encrypt that amount of data. But as you said, if you don't have the other mechanisms to protect your account in place.
Exactly. Then it's all gone. If someone breaks into your AWS account, you're lost. Okay. Then thanks everyone.